Ready to start. Hello everyone and welcome to another webinar in the series of webinars that we're running here at PerfectScale, where we invite some exciting smart folks from the industry. And today I'm more than excited to have Zbyněk Roubalík with me. Zbyněk, you are the CTO at Kedify, which is a company behind KEDA, the open source Kubernetes event-driven autoscaling project, and you're also a maintainer of that project, and I'm very happy to have you with us today.
Thank you, Anton. Thank you. I'm happy to be here today and talking about KEDA, my favorite project in the Kubernetes space.
Mm-hmm. How long have you been maintaining KEDA?
I'm actually maintainer since the beginning, so I'm like with the project since the start of a project. It started a couple of years ago when I was employee at Red Hat, and we did this cooperation with Microsoft. It was Microsoft and Red Hat cooperation, trying to figure out a bunch of things on Kubernetes and especially around autoscaling. So we tried this POC, this project.
Mm-hmm.
It was successful. It seems to be nice. So we open source it and then donated to CNCF Foundation, and that's how I end up here today, actually.
Exciting. So wonderful. So today you'll give us a presentation, basically an overview of what event-driven autoscaling is, what it brings to the table, and how KEDA implements it on Kubernetes. And then in the end, we'll also have a demo, right?
Yeah. We will have some demo in between, and we will talk about KEDA and about the challenges with autoscaling with KEDA. So yeah.
Wonderful. I'm sure many folks here are interested in how to implement event-driven autoscaling, or maybe some are asking why they would need event-driven autoscaling or how to better implement it and to benefit from it. So folks, we're trying to do this as interactive as possible. So while Zbyněk is telling his story, if you have any questions, we have the Q&A section, so feel free to send us your questions. I'll ask Zbyněk to answer, and we'll also be running some polls, so make sure to provide us with your answers. And without further ado, Zbyněk, the slides are all yours.
Thank you. Okay, so again, hello everybody. This is like short agenda. The intro, we did the intro, right? So then we will talk why autoscaling matters, actually. This will bring us to KEDA. So I will do a very quick overview of what KEDA is. I believe that there are some people that I hope there are some people that already know what KEDA is, but I would like to also give an overview to newcomers. I will discuss some features of KEDA, the architecture, maybe some advanced features that you might be missing. I will discuss HTTP-based autoscaling because this is related to event-driven autoscaling, actually. And then I will spend time discussing the challenges that you might have with implementing autoscaling at your solutions, and also about the future. So again, you already introduced me. So my name is Zbyněk. I'm founder of Kedify, basically provide enterprise features on top of KEDA. I'm KEDA maintainer, and the rest of the stuff we already discussed. So I suppose we don't have to spend time in here. So why event-driven autoscaling matters, or just autoscaling? Why it matters? Let's say that you are about to deploy some application, some platform that you are developing, and you would like to deploy it on your cloud platform. So it could be Kubernetes, because we are talking Kubernetes today. So you are about to deploy this application to Kubernetes, and this application needs certain amount of resources. So it could be containers. So if you look at the left diagram, the yellow box represents the amount of resources that we assign to the application. So it's about 15 containers at this specific example. And then as users are using this application, they are making load. This load is represented by the red part, by the request. So basically, this is the amount of resources that we need to to successfully process the load that is coming to the application. So as you can see, for some, if we define all the resources statically, we assigned those resources to our application statically, we see that for a certain period of time, we have way too many resources created, and sometimes we don't have enough resources created. So this is like the static definition of the application and the platform. If we enable autoscaling, we are able to basically assign as many resources as we need at a certain point of time. Because as you can see on this diagram, and as we all know from the experience, the usage of our applications usually varies across the time. So basically, it's different in the evening, different in the morning, different on the weekdays, weekends, etc., etc. So basically, we would like our infrastructure to reflect the need for the applications and for the platform. This brings us to this topic about resource requests and limits, because as we discussed just recently, the amount of requests coming to our application varies across the time, but also each application and each part of the application has a different size and resources requirements. So basically, each application is different. It needs different amount of CPU memory assigned, etc., etc., etc. So we might face two big problems. One is under provisioning, so we don't have enough resources to successfully run our application. This might cause outages, latency, and overall bad UX. Or we can see over provisioning. So we have way too many resources deployed, many Kubernetes nodes, and we are spending too much money. This is expensive, wasteful, and I believe that no one would like to do that. Everybody would like to save some money on the infrastructure. So I think this is important aspect when we are talking about autoscaling. We need to think also about this, because autoscaling in fact is just creating a new replicas, new pods, creating a new containers on your Kubernetes cluster. And I think that I believe that you guys at PerfectScale are dealing with exactly this kind of stuff. So this is important thing to mention here. So why autoscaling matters? As I told you, because application require different resources during the time. Also, resources requirements for CPU memory and resources also varies across the time. So we need to bring this elasticity into our system. So we need to elastically change the infrastructure and the application, so we don't over provision or we don't under provision. So all users are happy. We don't spend too much money. And when we are talking about autoscaling, there are two things on Kubernetes. There are two things to realize. There is a pod level autoscaling, so pod autoscalers, and cluster level autoscaling, so cluster autoscalers, so adding nodes. And to be able let's say that if you would like to have a properly configured system, you should configure both layers of this autoscaling infrastructure, because pod autoscaler, by scheduling, by scaling out deployments and pods, is making a pressure on the cluster autoscaler, which in the end schedules nodes or destroys nodes in the Kubernetes cluster. So you would like to have like this proper configuration on both sides, so your application can scale elastically and properly. So this is the autoscaling. Let's say why do we need it, and what is the autoscaling problem? So let's say that we have this application. It's plain Kubernetes application, and it is consuming some data from some external system. So this could be message queue system or some database or whatever. In this specific example, it is Apache Kafka. And Apache Kafka has these topics and messages stored in the topics, and our application is consuming those messages from the topic. And we just discussed that we would like to bring the elasticity into the system. So we would like to autoscale the application, right? So we don't over provision or under provision. So what are we gonna do? The straightforward thing on Kubernetes is to plug HPA, the horizontal pod autoscaler, which is built in Kubernetes, that is able to autoscale the application based on the CPU or memory consumption on the application. So it monitors the application, and based on the resources we define on the application, and based on the actual consumption, it scale out the deployments or pods, sorry. But this is not an ideal for all situations and for this specific example. because we are talking about event-driven systems today, and event-driven system usually, if we can talk, in a short sentence, it's basically you would like to design an application that can react to particular events, and just each part of the application should do only job when the particular event is happening. So in this case, they would like the application to be running and to consume messages only when the messages are in the Kafka queue. So for example, if there are no messages in the Kafka queue, ideally we would like to scale the application to 0 replicas, so we don't spend any resources, any containers. And if there is a long queue in the Kafka topic, we would like to scale out the application. And it's important to realize that basically monitoring CPU and memory consumption on the deployment doesn't correlate with this actual need, because this doesn't reflect the need for the scaling. Ideally, you would like to scale out based on the Kafka topic, right? So the proper solution is to bring KEDA in. So basically, KEDA can scrape the metrics from the external system, from Apache Kafka, by monitoring the Kafka topic, and it can scale the application to 0, or it can scale it out to whatever replicas are needed at the specific moment. I don't want to say that scaling based on CPU or memory is bad practice. No, it is not. For particular workloads, it's very good, and the best metric actually, because some workloads are heavy, are doing some computation, some stuff like that. So this is ideal use case for CPU and memory. But there are a lot of other applications and deployments that rely on some external services, external metrics, external events happening in some other parts of the system. Or we would like to collect some custom metrics. So the application is exposing some metrics about what is actually doing. So for example, these days, everybody is trying to run AI ML models, inferring and training the models, etc., etc. So maybe our deployment could expose metrics about tokens and metrics related to this kind of stuff. So we can just easily consume those metrics and scale based on that. Mm-hmm. So this brings us to KEDA. So maybe we can ask the audience if they are familiar with KEDA. Actually, I would be interested to hear that.
Yeah. Okay. We'll start running some polls. Meanwhile, okay, let's talk a little bit about KEDA, and I already have a couple of questions for you, but I guess after.
Go ahead with the questions. Yeah, go ahead with the questions.
No, actually, there are questions about KEDA, so maybe you should first.
Okay.
Give us your pitch of what KEDA is, and then we'll.
Sure. Okay, so what is KEDA? KEDA tries to make Kubernetes event-driven autoscaling that simple. So basically, our goal from when we started the project, our goal was to make the autoscaling simple, from the user perspective, so user can easily configure this. It should react to events, so it should be event-driven. It should allow scaling to 0, and all this kind of stuff. Scale to 0, we can do that with KEDA. We cannot do that with HPA. So we solve this. Then their HPA is also able to consume some external metrics, not just CPU memory, but you need to write your own interface, own metrics adapter, etc., etc. So there were some people utilizing, for example, Prometheus adapter to feed those custom metrics to HPA to do the scaling. But the configuration is very, very, I would say, very complex and very difficult to actually maintain in a larger scale. So our goal was really to make this configuration really very, very simple. With KEDA, you can scale any workloads or schedule Kubernetes jobs based on events. What is scheduling jobs? There are Kubernetes jobs on Kubernetes. I suppose everybody knows that. There are cron jobs that run this particular job in a cron schedule. And we have scale jobs. Scale job, you can imagine it as a cron job on steroids. So basically, based on the same events happening in some system, we can create jobs and consume some stuff. We have plenty event sources that we can use to drive the actual scaling. So it's around 70 these days, I suppose. It's Prometheus, RabbitMQ, Kafka, Redis, you name it. There is a KEDA community. We already talked about this. So the project has been started originally by Microsoft and Red Hat, then donated to CNCF. We have more than 400 contributors, this kind of stuff. And there is a survey for the KEDA users. So if you are a KEDA user, please fill the survey. It helps us, to shape the project and to know what should we focus in the future. I will also share this QR code at the end of the presentation. There are some users from the community. I suppose we can skip this. Let's go to the more interesting stuff, to the internals.
Yeah, well, okay, maybe before we go into internals, so here is a basic question. Basically, I think you've answered this, but maybe to summarize it for the audience. So Janie here is asking, what are the pros and cons of using KEDA versus HPA based on CPU and memory? So what are the pros and cons basically of event-driven autoscaling versus, resource-based, I guess?
Exactly. Basically, as I described in the autoscaling problem, there are certain workloads that CPU memory metrics are enough. But once you would like to depend on some external metrics, on something, the application is consuming something from the external system, then it's much better to use KEDA and to do that. KEDA builds on top of HPA, so you don't lose these capabilities actually with KEDA.
Yeah. Well, one thing that and you tell me if I'm in the correct direction. I have this line of thinking saying, basically, scaling based on resources is kind of reactive because you see the increase in resources and then you do the scale out process, right? Where with event driven, you're saying there are events that will cause an increase in resources and you're doing scaling a bit more proactively.
Exactly. Yeah, exactly. We have sometimes when we are doing these talks, or my colleagues, we are using like this pizza story, basically, that basically you are serving pizza or beer to the audience, to the people, and you don't want to scale, for example, the tap when you are serving the beer based on the flow of the beer from the tap because you see a lot of people, but you would like to do that because you see long queue of people coming to get a beer, or you see them in the doors, entering the venue. So you would start, immediately scaling out the taps with the beer, so you can serve them all. Yeah.
Yeah, and you want to have those kegs ready.
Exactly.
Okay. Cool. So this one's answered, and now let's dive into KEDA's internals. Cool.
So KEDA is built on top of Kubernetes. So from the day one, we were like, okay, there is like an autoscaler and all this kind of stuff already present in Kubernetes. So we don't want to reinvent the wheel, basically. So let's reuse what is beneficial for us. We just define a bunch of additional stuff on top of what is built in Kubernetes. So we have like this scaled object or scaled job resources. I will get into the explanation later on, but basically this is a resource where you define the scaling settings, scaling configuration. So let's say that I would like to scale out some workload. So I will create this scaled object in my Kubernetes cluster. And if we look at this diagram, I will create a scaled object, the blue circle. And then KEDA is notified that there is a new resource and it will start processing it. There is a main component in KEDA, which is KEDA operator. The operator processes this scaled object, it validates the data. And basically, for example, if we are talking to Kafka, so we would like to scale out based on the Kafka topic, it opens the connection to the external Kafka broker, which is defined in the scaled object, and start scaling. And because HPA cannot scale to zero, naturally, because if you think about it, if you are using HPA to scale based on CPU or memory, and you scale the workload to zero, in this specific moment, you lose the source of the metric. So you cannot wake the deployment again to at least one replica. So you cannot do that with HPA, but with custom metrics or external metrics that are not specifically bound to the workload, but to other systems, you can do scaling to zero very easily. So basically, KEDA operator does the scaling from zero. We call it activation phase. So it activates the workload. And then from scaling from 1 to whatever maximum replicas you have defined, the scaling itself is done by the HPA. HPA has this interface I talked before. So basically, it allows KEDA to plug into this interface through the KEDA metrics adapter, which is the other component of KEDA. And basically, HPA is notified that there is a new workload, and it requests a metric and data for this metric. So it can validate the workload, and it can decide how many replicas of the workload do we need. So basically, this request is propagated through Kubernetes server all the way to KEDA metrics adapter and to the KEDA operator, which does the actual call to the external service, to Kafka, and it returns the value. So then the HPA is doing this kind of scaling from 1 to n. This brings us this benefit that basically we can reuse the concepts from HPA, such as configuring the behavior, etc., etc. This also brings us or brought us some limitations of the HPA. I will discuss them later on. But this is basically how KEDA operates in a nutshell. We did some architectural changes in the past, but basically majority of the work is done by the KEDA operator. There is one thing I would like to highlight, that you can have only single KEDA instance in a cluster. And this is due to the limitation of Kubernetes server. There is this interface to provide external metrics, and there is only one this interface per cluster. So only single tool can occupy this endpoint. So there were some, for example, issues with Datadog, because the Datadog agent has been using also this interface. We work with Datadog, so they are now able to work with KEDA properly. So we can do that. Yeah, and the important part of KEDA is the scalars catalog. So KEDA has like 65 plus different scalars where you can just define the stuff you would like to do, and you can auto scale. Important thing, KEDA does not manipulate the data itself. So if your application is consuming messages from Kafka, KEDA doesn't know anything about the actual content of the data. It just monitors the metrics. It doesn't manipulate data, so the application needs to deliver the metrics themselves. If you would like to plug KEDA into your existing setup, usually you don't need to do any changes to the application. You just need to be sure that the application is, let's say, cloud ready. So basically, it's stateless. It is fast. It can fast. It has a quick start basically, so it is not loading too long, and basically this kind of stuff. I missed the results from the first poll. Anton, could you please?
Yeah. So it looks like a quarter, 25% of our audience are already using KEDA. 40%, I think, are not using KEDA, and the rest are thinking about using KEDA, evaluating the solution. So I'm sure this will bring all of them a lot of value.
Cool. This is great. I'm happy to hear that there are some KEDA users, but also some newcomers. So we have this great mix, I suppose. Perfect.
Yeah, and we also have a question here, which I think you somehow answered, like the question: is it possible to use KEDA instead of HPA and VPA?
No. Okay. To answer to this question. Yes, you can use KEDA instead of HPA, because KEDA under the hood, when you create a scaled object and KEDA opens the connections, in the end, KEDA also generates HPA object, HPA resource. So you can also define the very same CPU memory resource scalars that are used with HPA. So you can, it's a one-to-one basically a replacement for HPA, because it still uses HPA under the hood. For VPA, no. I think we will also discuss this later on. Usually, mixing VPA and HPA in a single deployment is not good at practice. So basically, you shouldn't do that, because HPA will tell the workload to scale horizontally on the same metric, and VPA will tell it on the same metric to scale vertically. So it will clash. So you shouldn't do that. Actually, you shouldn't do that together.
Definitely. And if you still want to achieve vertical pod autoscaling on HPA based workloads, look into PerfectScale, because we know how to do it.
Perfect. That's perfect. I can see also. Yeah, go ahead.
No, it's fine. We're done with this question, and yeah. Okay, and yeah, we have some results regarding scalars. So it looks like 30% of the respondents are using it KEDA with Prometheus, 18% with Kafka, There are some folks using it with Redis. 30% are using cloud-based scalers, AWS, GCP, and Azure. And we even have 18% that are saying that are using additional scalers. We don't know which ones.
Perfect. I will probably a little bit speed up because we have a lot of stuff to cover and not enough time, I suppose. So scaling is one thing. So you would like to scale your application, but also important thing is security. And because you are using these scalers to talk to the external systems, you would like to authenticate to these external systems, for example, to Kafka. So KEDA supports all the authentication mechanisms. So you can specify secret in a vault, in HashiCorp vault, Azure vault. You can use secret managers or identity providers from all the major cloud providers. So we got you covered on this. The same thing is about monitoring. You are scaling the workload, but you would also like to know what is actually happening with the auto-scaling solution. So KEDA expose a bunch of Prometheus metrics, or if you are consuming OpenTelemetry, we are also exposing OpenTelemetry metrics. And recently, we slowly starting adding also cloud events. Cloud event is more like a event-driven monitoring, I would say. If you don't know what cloud event is, it's basically, you can imagine it as a unified wrapper around arbitrary data that you can send over across the system. And through this unified interface, there are many connectors that can consume this event. So basically, it's a wrapper around some data. And we are playing with KEDA basically to fire a bunch of cloud events. So for example, imagine for example, the KEDA woke up deployment from 0 to 1. So we would like to send some event to some other system. So we can send a notification. Okay, this workload has been scaled to 1 replica. Stuff like that. So we have not like a full coverage of cloud events in KEDA, but we are slowly building these capabilities. This is especially, I would say, important for let's say cloud for platform providers that are integrating with KEDA, that they can plug different other components to it. Okay, so let's go to the.
There's a lot of magic in auto scaling, so you definitely need observability for that.
Totally.
Understand what's going on.
Yeah, so let's talk about the actual auto scaling of Kubernetes workloads. So as I mentioned, you can target any workload on Kubernetes. So it could be deployment, stateful set, or any custom resource that just implements a scale sub-resource. Basically, this is a sub-resource that Kubernetes is using with resources to enable scaling. So once you have this, you can use it. And if you look at the example of a scale object, it's very simple. This is like a simple configuration. We have a bunch of configuration options and knobs, but basically there are 3 main parts. The first part is a scale target. So basically it's the reference. So what workload I would like to scale. Then what is the minimum, maximum of replicas? And then the trigger section. So in this case, it's a RabbitMQ trigger. And in the trigger section, we basically specify where is the RabbitMQ instance, and then the queue that we are using to target and the queue length. So basically the threshold for scaling. We can specify multiple triggers in a single scaled object. So we can scale based on different triggers for the same workload. Okay, so I will switch to demo. I will show this in action. This is probably better than. Okay, I need to figure out.
Okay, while you're getting ready, I'll answer a few questions. You just correct me. So there's a question here. What's the difference between KEDA versus HPA with custom metrics with Prometheus? So basically, I would say, first of all, ease of setup, right? It's much easier to integrate HPA with Prometheus with KEDA. Yeah, and exactly. Also, once you have KEDA, you have the 65 plus additional scalars besides Prometheus that you could use with it.
Exactly. Basically, if I'm not mistaken, the Prometheus adapter is using a single, maybe it's a config map to define all the scaling settings in a single place for the whole cluster. We have like settings based on each workload. Okay, so I will try to show you this example I show you in the slide. So basically, I don't show you basically it's the Apache Kafka consumer consuming messages from Kafka topic. In my cluster, I have deployed StreamZ. So StreamZ is like operator to create a Apache Kafka cluster. This cluster is running in EKS. And I have a consumer consuming messages. So you can see there is a single replica of the consumer. In the middle section, you will see the output from the consumer, and I will just generate the load. So first, I will show you the deployment. Very simple. Is the typical Kubernetes deployment. I'm just targeting my Kafka broker in my cluster. Nothing fancy here. And I will generate load. I will create a Kubernetes job that basically it has a producer that basically connects to the same Kafka broker and sends 15 messages. So I will create this. Okay. I will create this Kubernetes job, and shortly we will see that these messages have been processed by the consumer. So we know that the setup is working. I hope so. That we will see it in the output. Actually, let me refresh it. Okay, so we can see that we received 15 messages. So it is working. Perfect. So now let's enable auto-scaling. So I will create a scaled object. So again, the scaled object is very simple. It's down below. So you can see I'm just defining the trigger and minimum, maximum replicas, and that's it. And I'm targeting my consumer. So I will deploy this scaled object in the bottom, and shortly you will see that the workload, the consumer has been already scaled to 0 replicas because there are no additional messages. So we can scale to 0. And now let me clear this up. I will generate the load again, but this time I will generate a little bit bigger load. I will not create 15 messages, but 500 messages. So I will create a bigger load, and shortly we should see that basically the application will be activated, and we will start consuming the messages. As you can see, it's already been scaled to 1 replica, and shortly, as the load is increasing, HPA will scale out to more replicas for this particular deployment. If my cluster is not fast enough, I need to create more messages to show this capability. Okay. Okay, let me. Yeah, so you can see it has been scaled to 2 replicas. Already, and it will scale to many. If I enlarge the load, basically we can dynamically change that. I suppose that my cluster is healthy enough and it can withstand the load, so I might increase the number. Okay, it's already 4 replicas, and it will scale up to 5 replicas, which is the maximum. But we consume all the messages, and it's been already scaled to 0. I have configured the config for the scaled object that way that basically the scaling is very fast. Also the scale to 0. So there is this cooldown period, which is basically how long should KEDA wait until we process the last message before I scale to 0. So this is set to 5. This is in production. You probably don't want to do that, but for demo purposes, this is also good. And to activate the scaler, so to activate the scaling from 0 to 1, there is this configuration called polling interval. So basically, KEDA periodically every 10 seconds poll the Kafka broker to see if there are new messages basically in the queue. So by configuring this polling interval, you can achieve flexibility in the scaling. Okay. So I hope that this was somehow self-explanatory for the.
Yeah, definitely, and it works very fast. Like comparing to how HPA usually reacts, it's much more immediate.
Okay, so let's go to the advanced features. So one feature I would like to highlight is a fallback. I wouldn't even consider it as an advanced feature. I would encourage everybody who is already using KEDA to specify fallback. So basically, the fallback is the configuration for you to mitigate problems with the external service. For example, imagine that you are scaling based on the Kafka topic and the Kafka cluster is down. What should we do in this case? So we would like to probably scale to some safe amount of replicas for this scenario. So for that, the fallback feature is built. So I will show it very quickly in the action, so you can see it actually. Let me do it like that. So I will show you. So I'm using for that. I will describe the scale object a little bit. I'm using our dashboard that we have with Kedify that basically allows you to install KEDA installations across your fleet. I have the KEDA installation on my EKS cluster. So I will check the scaled object. This is the consumer scaled object. You can see this is the load. It withstand it, and basically the configuration there for the fallback. You can see I don't have specified fallback. So I will specify the fallback that basically there is a fail threshold. This says that if there are, for example, two errors, two failures coming from the service, let's scale to this amount of replicas, or you can specify it, for example, to 10 errors. So you don't fall back too early. So let's say for this specific use case, if there are two errors coming from the service, let's scale to 3 replicas. So I just updated the scaled object, and now I will make some disruption in my Kafka setup, and I will do it that basically I will delete the Kafka topic and the Kafka installation from my cluster through these resources. So I deleted the Kafka from my cluster, and you can see that already the workload has been scaled to 3 replicas, which is basically the fallback that I specified for me. So I would highly recommend you to use fallback for any setting. And there is actually a feature open and pull request open that you can use basically in this specific setup. You need to specify the amount of replicas you would like to use, but we are extending this feature that it will allow you to use the actual current number of replicas that is in the specific moment when the scaler fails to specify the fallback. So this was fallback. Other interesting feature is a scaling modifier. So scaling modifiers, what is it about? As I told you, in a single scaled object, you can define multiple triggers. So in this example on this screen, you can see that I have 2 triggers. I have Kubernetes workload trigger and metrics API trigger. And as I told you, we rely on HPA with just some benefits, but also some limitations. And this is one of the limitations of HPA, because what HPA does, it basically consumes all the metrics and then selects the largest value for the scaling decision. So for example, one metric is telling HPA to scale to 2 replicas, the other is telling it to scale to 5 replicas. So HPA will select the maximum, so it will select the 5. Sometimes you would like to use average or maybe minimum or some other value. So we introduced this scaling modifier feature, and we did it basically that it accepts any mathematical or conditional statements. So you can write this formula, like very complex formulas for the triggers. So in the example, the formula is value from trigger 1 plus a value from trigger 2 divided by 2. So basically average, but you can use even conditionals, etc. So we are doing this pre-calculation on KEDA side and then send just single metric to HPA. So this way we can achieve minimum, maximum, average, and all this kind of stuff. This is very interesting feature, and if you have specific use cases, this might be very powerful. And I would like to say also that this feature is not only powerful when you have multiple triggers. It could be also used when you have only a single trigger. There is this quote from a user when I was talking to this user, and we were discussing his setup, and he mentioned that we have this requirement to be always over provisioned by 3 pods for our workload. How we can do that? And a single pod can process 3 messages at a time. But by traditional means, you cannot achieve that, because it's very hard to tell HPA to do this kind of stuff. So I was like, okay, let's try scaling modifiers. So let's specify the formula trigger value plus 9. Why 9? Because it's 3 pods and each pod has 3 messages. So it's 9. So, and the guy tried it and it worked for him perfectly. So this is also like, there are a lot of possibilities, and it really depends on the specific use case that you might have with your setup, but you can achieve very good things with this feature. This brings me to scheduling Kubernetes jobs. So right now we auto-scaled Kubernetes workloads. but we can also schedule Kubernetes jobs, as I mentioned. If we look at the resource, we can see it's very similar to the scale job, scale object, excuse me. So you have some, but instead of the reference to some Kubernetes workload, so to the deployment, you can paste the whole Kubernetes job definition in there and use the same settings that you are using for scaled objects and the same triggers. So in practice, for example, this scale job, if we define some job, so basically some container there, it will create this container when the specific condition is met. So for example, if the queue in the Rabbit is longer than 5, it will create a single job, and it can do something about this particular workload. Why is this useful? It is useful to handle processing of long-running executions, because if your workload, if you are scaling some workload and this workload is doing some work, and this work might take minutes or maybe hours, to process the whole stuff, what could happen that actually you scale out the workload with HPA or scaled object, and you start processing the work. But in the middle, HPA might decide, okay, the metric is no longer that high, so I would like to kill basically the replica. So I would like to scale in again to lower amount of replicas. So basically, you cannot achieve this with HPA or scaled objects. This long running processing. And this is exactly the job for Kubernetes jobs, because job has some start and an end. So basically, we are just adding the flexibility to create those Kubernetes jobs based on some custom metrics or the events. So if we are talking about event-driven autoscaling, this feature is not using HPA. We are basically just creating those Kubernetes jobs from the KEDA operator. So this was the, let's say, KEDA in a 15 minutes or whatever it took. So are there any questions related to the basics of KEDA?
Well, there are lots of questions. I've been answering some of them, typing them while you were speaking. There are some questions here which are like, they look like production issues that folks want us to solve. So I'll leave these to the end if we have time. Okay, so there's a question here. There's a single KEDA operator that can be active at a given time, right? We can run 2 pods and they have some kind of master election, right?
Yep. There is, like the KEDA operator can be scaled to whatever replicas you would like to do, but in a single time there is only single controller handling the requests. Mm-hmm. The limitation itself is about the metrics adapter component, because there were some people that were asking, we are running like a multi-tenant installation on our Kubernetes cluster, and we would like to install separate KEDA instance for each tenant so it doesn't interact. But unfortunately, this is not possible, because this is going all the way down to HPA and how it talks to KEDA through this interface, and this interface is only single one in the cluster.
Yeah, it works through the API, Kubernetes API extension.
Yes, it's external metrics endpoint.
Okay, gotcha. Okay, so we covered this one. How do you see the benefits when it comes to node pool types, optimization of node pools? I understand we can use the nodes more efficiently, but okay. So basically somebody's asking here if KEDA benefits the node scaling in any respect.
I will probably get into this later in the talk, so maybe we will cover this later on.
Okay, cool. And is KEDA free to use? How is it different from Kedify?
Yeah, so KEDA is open source project. It's free to use. Kedify is basically built on top of KEDA. So we add a bunch of, let's say, enterprise features with support, with these dashboards, security fixes, and basically our goal is to still support a project and to serve our customers who has like a specific needs or larger deployments or needs some specific features. Because when I was talking about the project, our goal was to just really make the Kubernetes event-driven autoscaling simple. So we try to solve single purpose with KEDA. We don't want to create like this tool from KEDA that does 10 different things and not good. So our goal was like to make it really simple, like this process from Linux, for example, or Unix, whatever. So this is basically the distinction. The core is KEDA, and with Kedify we build on top of that. But these capabilities I show so far, they are present with the open source version, so you can use them easily.
Okay, and when will the HTTP scaled object be available for production use?
I will just get into this in the next slide.
Okay, cool. So let's go into that, and we'll look at the questions later if we have time.
Cool. So HTTP-based scaling. So far we discussed like we discuss auto-scaling on Kubernetes with KEDA. And let's again go back to our problem. So as you can see, there is like this guy. It's probably Anton, right? Because it's the mustache is the same. It's a coincidence, I suppose. This is not fun, but basically, Anton makes an HTTP request, and he wants to, his request to be processed by some application by HTTP server. So sounds trivial. That's fine. But if you would like to auto-scale this application based on the HTTP request, this might be tricky. So if we revisit the previous example with Kafka, KEDA, like by nature, utilizing the event-driven autoscaling, it is using pool model. What does it mean? It's basically that the application, like this part, the application is responsible for pooling the data itself. So KEDA or like the infrastructure is not responsible for sending the data into the application. The application need to pull the data from some external system. So this is the pool model. So for example, it's very easy to do scale to zero because we can just scale to zero based on the data. Once there are data, we scale the workloads to one replica, and the workload will pull the data. But HPA traffic, by its nature, is not pull; it's push, because Anton sends the request to the workload, and he wants it to be processed. There is not the application itself doesn't pull the HTTP request. So this brings a lot of challenges into the play if you would like to achieve real HTTP-based autoscaling on KEDA. But HTTP traffic is also an event, so it's event-driven. So we should be able to autoscale, right? So as I discussed, the challenges, the push versus pull model. We need to transfer the actual data, and for example, there are some use cases and people how they achieve HTTP scaling. They are using the traditional setup there is a Prometheus, and they are not scaling to zero. So they are scaling to, for example, from one replica to whatever, and they are using Prometheus to scrape metrics from the application about HTTP requests, and based on that, it performs scaling. This is doable. This might work for certain use cases, but usually with the HTTP traffic, you would like to scale close to real time because the traffic might have some timeouts, and you would like to see the output very, very fast. So this is another challenge, close to real time. Scaling to zero, also the problem, because once we scale the application to zero, Anton makes the request. The request comes to the application, and the application is down. So we see 500, 400, whatever response from the application, and this is bad UX. We don't want to do that. Other issue.
Angry.
Yeah. Anton is angry, and then what is also angry, it might be like a monitoring tool that Anton is using at his cluster. So this monitoring tool might use some HTTP-based health checks. So basically, it periodically pings the workload if it is ready. Once we scale the application to zero, this health check might not be successful because we are targeting the application scale to zero, or these health checks can actually cause the scale out, so like the activation. We don't want to do that, right? And also, HTTP traffic is not just HTTP requests. It is gRPC, WebSockets, TLS, and whatever other protocols you might achieve. So this is I would like people to realize that this is not something that it's as easy as do. So all these questions like, why don't you do that in KEDA? It's harder to achieve, but it's doable. So this brings us to the solution that you can do. What would you like to do is basically somehow handle the traffic, incoming traffic, get the metrics in real time, and scale the application based on that. There is an HTTP add-on for KEDA, open source version. It's been it's been development for a long time, and it's not in very active development, actually, honestly. So There is not much traffic, not much contribution. So I wouldn't definitely recommend it for production use. I know that there are some users using it successfully. So for some use cases, this is perfect, this is doable. If you don't have higher load, it's fine. But it is not, it is still beta. I wouldn't recommend it. And basically what it is using a different resource called HTTP scaled object, where you define a bunch of options, and it tries to do that. There is an interceptor component. Basically, all the traffic is going through this interceptor component to your workload. And based on the metrics coming from the interceptor component, you are able to scale out the workload and also scale to 0. But this interceptor component is also I would say, the problematic part, because it needs to handle a lot of stuff. And at the moment, it's not very, very good. So if there are people asking about it, just contribute or try it. It's doable, but not there yet. The better answer is actually we at Kedify build our own scaler. At the moment, it is our, let's say, paid offering or product offering, because we need to fund the business somehow, because we need to support the project, but still we need to make some money to be able to do that. So basically, one of these extra features that we have is a HTTP scaler. We support scale to 0. We support all this kind of stuff I discussed. We have a fallback there. We have automatic configuration, and it also integrates directly with scaled object. So basically, it is using the same scaled object, and there is just different type of trigger, just Kedify HTTP trigger. And you just specify the workload, the host and service and port, and basically the metric how you would like to auto-scale the application. I will show it to in action. It is similar experience to the open source version, so you can see it in action actually how does it work. If we look at the terminal, you can see that there is a HTTP server running as a single replica without any auto-scaling, and I will show the definition. It's very simple, traditional deployment. So it is a single deployment HTTP server. It adds some artificial delay to the response, and it just responds back with the 200 OK. I was able to process the request. There is a service, Kubernetes service, typical thing, port 8080, and we have ingress object. And in the ingress object, I specify the host name, the host for this particular workload. I'm running this on my EKS cluster. So now, if I make a request to this cluster, this is curl request with the host name, I'm getting the 200 response from the application. So it is able to serve the traffic. And now I will enable auto-scaling. So I will show it to you in our dashboard, so I can explain the features a little bit. So I will create a new scaled object. I will select the workload. So I will select the HTTP server. I want to auto-scale the HTTP server. This is the same settings in the scaled object. So minimum, maximum replicas. So I will scale from 0 to, for example, 10 replicas. I will specify the cooldown period. This is the stuff I mentioned. So how fast it should scale from 1 to 0. So I will specify 2 very low numbers. So we see in action in the demo. And I will also tweak the settings. These are settings for HPA, very same settings. How fast it will scale down. And I will add the trigger. I will spin down a little bit. I will just select the host name. And the important thing here is the scaling metric. So we can scale based on request rate or concurrency. The request rate basically tells us that the application is able to handle 10 requests, for example, per second. So 10 requests per second equals single replica. If there are 20 requests coming in the same time, it's 2 replicas. 30 requests, 3 replicas, etc., etc. Or concurrency. Concurrency basically tells you that the number of concurrently connected HTTP clients to the application. So I will create this scaled object, and I've also enabled traffic auto-wiring. So basically, we will automatically reconfigure the traffic a little bit, so we are able to achieve this scaling. So the scaled object has been created, and shortly you will see that it will scale to 0, hopefully. Yeah, so it's been already scaled to 0 after the cooldown period, 5 seconds. And now if I create again the request, the application will be started, and you can see I got the request back. So it has 200 with some cold start delay for the initial start. I'm gonna use this tool called Hey. It is able to create 200,000 requests to the same endpoint. So I will just generate some load basically. So we will see scaling in action. In the meantime, I will show you how we did that. So this is the architecture of the scaler. So basically, this is Anton making the request, coming to the load balancer ingress, and the traditional setup is going through the ingress service deployment. Once we deploy our scaled object, we automatically reconfigure the traffic that it goes through Kedify proxy. It's a small envoy proxy sitting in each namespace with the scaled object, where we have a scaled object. And it is the source of the real-time metrics for us. And it also routes the traffic. So for the traffic, when the deployment is scaled to 0, it scales the traffic through our interceptor service, and the interceptor will hold the incoming request. It will scale out the workload to at least one replica, and then forward the request back to the deployment. Once the deployment is activated, so there is more than one replica, or more than 0 replicas, the requests are coming just through this small hop through the envoy proxy to the deployment, and we are able to scale very, very quickly. The open source add-on sends all the traffic through the interceptor service, which is sometimes you are hopping through the different namespace, different node. So this adds additional delays. So this is one of the differences. So as you can see, the workload has been already scaled to 10 replicas. I will speed up a little bit. So this was the demo about the HTTP. Do we have any questions about the HTTP scaling?
No, not specifically about the HTTP scaling. And actually, we need to wrap up. This was packed with information, and we had a lot of questions. We won't be able to answer all of them, but I've saved them all. So we'll find a way to publish the answers later on. We'll forward everything to Zbyněk, and we'll find a way to publish the responses.
Mm-hmm. Yeah, okay. I have a bunch of other stuff in here, like some challenges, so maybe we can share the slides so at least people can check it out.
Yeah, we'll definitely share the slides too. And you have all of your like email and contact details on the slides, right?
Yeah.
So folks, if you have any additional questions, I'm sure Zbyněk will be happy to answer them when he's not busy maintaining KEDA and managing Kedify, of course.
Yeah.
And if you have
definitely.
any questions regarding the PerfectScale solution and how to optimize your cluster, so beyond horizontal pod scaling, and we saw a lot of questions here were related to how to combine this with vertical scaling, and this is definitely something that PerfectScale can help you with. We have a workshop at PerfectScale in the second week of February on how to optimize your Kubernetes clusters. And there is a code here you can scan in order to sign up for the workshop. I'll be doing that with Arthur, our VP of Product. And Zbyněk, I'm very grateful to you for coming, for doing this. This was actually packed with a lot of information that I think I've used KEDA in the past, but you've opened my eyes to some stuff that I wasn't aware of, and I'll be happy to collaborate with you in the future.
Awesome. Thank you very much for the invitation. It was a great session. Autoscaling is a complex topic, so as you can see, we haven't actually got into the real challenging stuff, but I'm happy to talk to anybody. So if you have any questions, feel free to reach out, or I'll be at KubeCon, so find me there.
Yes, see you all at KubeCon, and we'll consider maybe doing another webinar on this to dive deeper into the more advanced stuff, right?
Maybe we can do that. Yeah.
Okay, cool. Thanks everybody for joining, and may your pods scale indefinitely.
Awesome. Thank you very much. Bye.